Hello everyone and welcome to Unit 6, Day 2. So this is on parallelograms. So parallelogram should be a shape that you're kind of already familiar with, but we'll get into the actual, what that means for the shape. So, starting off with a couple of theorems. The first one says that if a quadrilateral, so a four-sided shape, is a parallelogram, then its opposite sides are congruent. And in this picture, you can see that our opposite sides are marked as congruent with those little lines. Those mean that those sides are congruent, opposites go across, and these two opposite sides are the same length. 6.4 says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So in a parallelogram, our opposite angles are going to be straight across the way like this. So those are marked congruent. And then so are these two. And those are also opposite. And then again, 6.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So consecutive means next to. So if you're looking at this parallelogram, our consecutive angles would be these two would be consecutive. These two would be consecutive. And then also these two and these two. So right next to, we're not going through the quadrilateral and adding those. And remember, supplementary means that those add up to 180. So in this parallelogram, JKLM, it's a parallelogram, so its angles, x plus y, add up to 180. Next, 6.6, if a parallelogram has one right angle, then it has four right angles. So in this parallelogram, we're told that angle J is a right angle, which means this angle is also a right angle, this angle is also a right angle, and this angle is also a right angle. Cool. So those are our theorems. Moving on to some examples. In this parallelogram, ABCD, we're going to suppose that angle B, this angle, is 32. And CD, this side, is 80. And BC, this side, is 15. Using that information, let's solve our problems. For A, we need to find AD. AD is this length right here. That's a terrible color. This one right here. AD. AD, remember, is an opposite side from BC, which means those are the same. So AD is equal to BC, because that's a parallelogram. And since BC is 15, then AD is also 15. There we go. Next, find angle C. So I'm going to erase my orange line. Angle C is this angle right here. Remember that in a parallelogram, the consecutive angles are supplementary, so they add up to 180. So if angle B is 32, then when added to angle C, it needs to equal 180. So angle B plus angle C has to equal 180. And angle B is 32. So we'll just abbreviate that to just C equals 180. I'm going to subtract 32 from both sides. So I get C equals whatever 180 minus 32 is, which is 148. And last is C, find angle D. Angle D is opposite, right here, opposite angle B, which means those are the same. So angle D is equal to angle B. So angle D is 32. Okay, on this one, we're just told that ABCD is a parallelogram. We need to find first AB. AB is this side right here, which is opposite side CD. So those are the same. AB is equal to CD. And CD is 30, which means AB is also 30. Next, find angle C. Angle C is this angle right here. It is opposite angle A, which means it's the same. So angle C is equal to angle A. And since angle A is 36, then angle C is also 36. And C says ABCD is a parallelogram, find angle D. Angle D is right here. Bam. It is consecutive to angle A, which means that those add up to 180. So angle A plus angle D equals 180. Well, angle A is 36 equals 180. So I'm going to subtract 36 from both sides, and I get D is equal to 144. Okay, moving on down. More practice. Number 1, I need to find the value of each variable. I'm going to start with finding x, because just I have 2 x's, and that'll make it a little bit easier. So I'm going to see this equation has an x and this one has an x. So I'm going to look at the relationship between those two. Those are consecutive angles in this parallelogram, which means they are supplementary. So I'm going to put angle G, which is this one, plus angle H, so this one, angle G, angle H, have to add up to 180 because they are consecutive angles. Consecutive angles are supplementary. So that's what I'm using. Angle G is also x minus 5, so I'm going to put that in there, and then I'm going to add on angle H, which is actually 2x plus 11, still equal to 180. I'm going to combine some like terms. I've got an x here and an x here, 2x here, which is total 3 x's, and then I've got a minus 5 and a plus 11, so that simplifies to plus 6. I'm going to subtract 6 from both sides, and I get 3x equals 174 divided by 3. So x is equal to 58. So the next thing I'm going to do is notice that since I've solved for x, so I could find the measure of angle G and angle H. I'm going to look more at angle H just because my y expression is opposite angle H, which means that angle is going to be the same. So I'm going to simplify that. So 2 times, I'm going to plug in my x that I just found, 58, plus 11, and simplify that. So 2 times 58 plus 11 is 127. So angle H is 127, which means that 2y is also 127. So 2y is equal to 127. I'm going to divide by 2. And y is equal to 127 divided by 2, which is 63.5. Great. Next one, we're going to solve for a and b. This one we can really choose whichever one we solve for first. I'm going to go for a. I'm going to notice that both my a expressions are on opposite sides, which means those are equal to each other. xy, side xy, which is this side, is equal to wz, which is this side. And xy is actually 3a plus 7, and wz is actually 4a. I'm just substituting in what those actually are. I'm going to subtract 3a from both sides, and I get 7 equals 1a, or just a. So that was easy, solve for a. Now I'm going to compare my b sides, which are xw and yz, and those are also equal because they are opposite sides. Let's go across. So I'm going to substitute in what those actually are. So b plus 11 is equal to 2b. I'm going to subtract b from both sides, and I get 11 equals 1b, or just b. That was easy. A and b done. Next, number 3. So I've got a parallelogram. I need to solve for x. X is over here. So this angle, angle L, is going to be congruent to angle J because they're opposite angles. So 75, that degree, is equal to angle L, which is 2x minus 1. I'm going to add 1 to both sides. Not 11, just 1. And I get 76 equals 2x. Divide by 2 on both sides. So x is equal to 38. Okay, number 4. Finding a and b again. I'm going to look at these opposite sides. So I'm going to start with a, I guess, and I'm going to look at these two sides, which are the same. So TS, this side, is equal to V W. Well, TS is A plus 15, so I'm going to put that here, and that's equal to VW, which is 3A plus 11. Subtract A from both sides. I get 15 equals 2A plus 11. Subtract 11. So 2A equals, oh wait, hold on. I'm running out of room. 15 minus 11 is 4, equals 2A. Divide by 2. So A is equal to 2. That was A. Now let's do B. B is talking about these sides right here. Those are also opposite sides. So I'm going to say TV is equal to SW, because opposite sides are the same. So 3B minus 17 is equal to B minus 11. I'm going to subtract B from both sides, so I get 2B minus 17 equals negative 11. Add 17. So 2B equals negative 11 plus 17, which is 6. Divide by 2. B equals 3. Great. Okay, we got 2 more theorems for parallelograms. These ones are about the diagonals. So the diagonals are lines that go through the parallelogram and connect the opposite corners, or the opposite angles. Like those. Those are the diagonals. In a parallelogram, the diagonals do bisect each other. So in this picture, bisectors, remember, just cut things in half. So this diagonal BD is bisected by AC, and the other way around. Bisected means cut in half. So this half BP is equal to PD, and AP is congruent to PC because those halves were cut in half by the other diagonal. And then 6.8 says, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So in this parallelogram, this is our diagonal BD, and it separates this parallelogram into one triangle here that's congruent to this other triangle here. 2 congruent triangles. Okay, let's do some practice problems. I know this looks complicated, but we're going to break it down. So it says parallelogram, or we're going to assume that this shape WXYZ is a parallelogram. So we need to find the value of R. R, if you look, is right here. That's the only part that has R. So that is talking about this side here, which is WX. Which means that this side is congruent to the opposite side, which is XY. So I'm going to write that. WX is equal to ZY, ZY. Well, WX is the 4R that we need to solve for, and ZY is 18. So I'm going to solve for R by dividing by 4 on both sides, and I get R is equal to 18 divided by 4, which is 4.5. Okay, number A, done. B, now we're finding the value of S. I'm going to erase some of my stuff here. S, I've got an expression for S right here. It's this part of the diagonal. And then another one right here, 7S plus 3, which is talking about this part right here. So remember the diagonals are bisected, which means their halves are equal to each other. So I'm going to say that those halves are equal to each other by setting the parts equal to each other. So 8S is equal to 7S, not X, S, plus 3. Solve for S, I'm going to subtract 7S from both sides. And I get S is equal to 3. Okay, next I'm finding the value of T. So T is right, there's a T here, which is talking about this little angle here. And, oh, so this should be fun. So this, we will tie this back to transversals. So when we have 2 parallel lines like these ones, these lines are parallel to each other. So it makes them a parallelogram. And a transversal, like this one, that cuts through those parallel lines. Then we have 2 congruent angles. In this case, this one is congruent to this angle right here, which is 18. Those are alternate interior angles. So I'm going to set those equal to each other. So 2t is equal to, what is that, 18? Because they're alternate interior. Solve for t by first dividing by 2. Actually, I think that's the only step we need to do. So t is equal to 18 divided by 2, which is 9. Okay, for guided practice number 2, I want you to go ahead and try it. It's very, very, very similar to guided practice number 1. So, it's like the same picture with different numbers. Go ahead and try it. Example 3, what are the coordinates of the intersection of the diagonals? Ooh, okay. So it gives us this parallelogram, gives us the points of it. So I'm going to plot those points. So -3, 0 is my first point, which is right here, M. Then I've got N at -1, 3, which is right here. And I've got P at 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Great. That's P. And I've got R at 3, 1. Right here. Connect those. Bam. 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 Okay, first, we need to connect the opposite angles. So the opposite angles will be going through the parallelogram. So our opposite angles here are N and R, connecting those, and M and P, which are these ones. And we need to find where they intersect. Well, using this graph, we can see where they intersect. Luckily, my lines are pretty okay. And that would be right here at point, what is that, 1, 2. So at 1, 2, the diagonals intersect. So diagonals intersect at 1, 2. Cool. Okay, number 6. We need to determine the coordinates of the intersection of the diagonal again. Again, it gives us more vertices to try. So let's plot those really quick. Starting with F. F is at -2, 4, which is right here. And then G is at 3, 5. 3, 5 is right here. G. And then H is at 2, -3, which is right here. And J is at -3, -4. So this is a big parallelogram. Let me connect those dots. Okay, there's my parallelogram. So I need to plot the diagonals so I can see those. Again, they will be connecting those opposite angles. So that's pretty good. And I'm going to go down the other way, connect F and H. Step 1, we want to name the diagonals. Okay, so the diagonals are FH and GJ. So connecting those opposite angles. Okay, so I'm going to do this one a little bit differently. You might look at this and be like, oh, it looks like it intersects right at the origin. But we don't know that. So I'm going to start by finding the slopes between the lines. So I'm going to find the slope of FH using the slope formula. So remember, the slope formula is y2 minus y1 over x2 minus x1. That's the slope formula, which we use M for. So my points F and H are the ones I'm looking at, F and H. So I'm going to take those and find my x1 and y1 and x2 and y2. Not y1, y2. Plug those in. Y2 is -3 minus my y1, which is 4, over x2, which is 2, minus x1, which is -2. Simplify this. -3 minus 4 is -7. 2 minus a -2 is +4. So that's my slope between those two lines. Okay, so I found the slope of my red diagonal between F and H. I'm going to try to make the equation of that line, and I'm going to use HK form to do that. So HK form, remember, is y equals m, my slope, which is negative 7 over 4, times x minus h, which will be one of my points, and plus k, which will be from another one of my points. So h and k are an x and a y from a point. So I'm going to pick a point to plug in for h and k. I'm going to choose h, just because. So my h and k will be 2 and negative 3. So let's plug those all in. Y equals my m, which is negative 7 over 4, x minus h, which is 2, plus k, which is minus 3. I'm going to distribute that slope. So I get negative 7 over 4x times, negative 7 over 4 times negative 2 is just plus 14 over 4 minus 3. And negative 7 over 4x stays the same, but 14 over 4 minus 3 needs to simplify. 2 over 4, which is just 1/2. So that's the equation of the line, which means it actually intersects, my picture's not very good, but it actually intersects like right there on the y-axis, because my y-intercept of that equation is 1/2. Okay, so that's the equation of my red diagonal. So now let's find the equation of my purple diagonal. Again, I'm going to find the slope between those. So I'm going to use my slope formula. Now this will be my new x1, y1, and x2, y2. So plug those in. Negative 4 is my y2, minus negative 1, which is 5, over x2, which is negative 3, minus x1, which is 3. So I'm looking at g and j. So this is the slope between g and j. This simplifies to negative 4 minus 5 is negative 9, over negative 3 minus 3, which is negative 6. So that both simplifies to 3 over 2. So this is my slope of GJ. So again, I'm going to find that equation of GJ. So y, I'm going to use this HK. My slope is 3 over 2. X minus an H and a K. So I need to pick one of those points to be H and K. I'll pick G. So my H and K will be 3 and 5. It's H and that's K. So minus H, which is 3, plus K, which is plus 5. Multiply those. And I get 3 over 2x. Negative 3 times 3 halves is negative, what is it? 9 over 3? Or 9 over 2? Plus 5. Okay, negative 9 over 2 plus 5 is, that stays the same. Negative 9 over 2 plus 5 is actually just 1/2. So notice how both of my graphs have an y-intercept of 1/2. So they both actually intersect right at that point. So their intersection, or the diagonals, intersect at, the y-intercept is written as 0 at the x, and then my y-intercept was 1/2. So that was a weird one. But we needed to find that y-intercept so that we would know where they intersected. We needed to find that equation so we could find that, because our pictures are not always accurate. That's it for day 3 on parallelograms. So we will see you guys, or was that day 3 or day 2? I can't even remember. Anyway, that's it for parallelograms. See you guys later. Bye.